everybody, and welcome to yet another wonderful session on your favorite YouTube channel Bhanzu. And here we are with a brand new chapter for grade 6. So if you know someone who is from grade 6, share this video with them right now. Let us get started. Welcome to Bhanzu classes. This is your educator Haripriya. Like this video by mark your attendance by liking this video. Also share this video with at least one friend of yours, and do not forget to subscribe to the channel, because this channel is one-stop solution for all your math related problems. Alright, so today we're going to start off with the chapter playing with numbers. Yes, we're going to play a lot with numbers in mathematics. So what are we going to learn in today's class? So in today's session, I'm going to talk about the introduction, about numbers. That's something that we already know because we have learned about whole numbers and all natural numbers. Then we'll be talking about factors and multiples, prime and composite number, and test for divisibility of numbers. Alright, so these are the 4 topics that we will be covering in today's session. This chapter is pretty big, so I have taken prime factorization, HCF, LCM in the part 2 of the session. Okay, so this is part 1. Now, talking about the introduction about numbers, there's a very interesting pattern that I want you guys to observe. So there are 18 marbles and we have to arrange them in different pattern. How can you do that? You can arrange all 18 in a vertical column like this, or you can arrange them into horizontal columns like this, where this is giving you the number of rows and columns. Or you can also arrange it as 9 multiplied with 2, like 2 rows and 9 columns. 9 rows and 2 columns, or 9 columns and 2 rows. There are different ways in which you can arrange the number 18. You can arrange as 6 multiplied with 3 or 3 multiplied with 6. Yeah, rectangles are forming, different types of rectangles are forming, right? So what did you observe here? 18 can be written as 1 into 18 or 18 into 1. It can be written as 2 into 9 or 9 into 2, 3 into 6 or 6 into 3, right? So these are the different ways in which you can write the number 18. Like, what are these numbers called and how are they related to 18? Now I can say that 1, 2, 3, 9, 6 and 18 are exact divisors of 18. That means they are the factors of 18. Now what are factors here? But before we move into that question, remember that numbers can be arranged in different patterns depending upon how many factors they have. So talking about factors and multiples, let us see which number exactly divides 6, leaving no reminders. Okay, so when I divide 6 with 1, I am getting the remainder as 0. When I am dividing 6 with 2, 0. 6 by 3, remainder is 0. 6 by 4, it is leaving a remainder 2. This one is leaving a remainder 1. 6 by 6 is not leaving any remainder, right? So what are the numbers that are exactly dividing 6 without leaving any reminders? 1, 2, 3 and 6. So these 1, 2, 3 and 6 are called as factors of 6. So what is the definition of a factor here? A factor of a number exactly divides that number. Let's talk about the factors of 81. I can write it as A1 into 81, 3 into 27, 9 into 9. So the factors are 1, 3, 9, 27 and 81. I can say that these numbers exactly divide 81. Matlab, if I divide 81 with any of these numbers, I will get the remainder to be 0. So that's why these numbers are called as the factors of 81. So factors of a number divides that number exactly. What do I mean by that? It leaves the remainder 0. So factors of 81 are 1, 3, 9, 27 and 81. Now there are a few things that you have to remember when it comes to factors. The first one is 1 is a factor of every number. Irrespective of what number you take 9, you take 81, you take 18, 1 is always a factor. And the number itself is also a factor. When we spoke about the factors of 81, you see 1, you see 81 also. When I spoke about the factors of 6, you see 1 and you also see the number itself. So remember, 1 is a factor of every number and every number is a factor of itself. Alright? Every number except for 1 has at least 2 factors. 1 ka factor is just 1, alright? But every number except 1 has at least 2 factors here. A factor of a number is always equal to or less than a number. So if I talk about the factors of 6, so we saw 1, we saw 2, we saw 3 and we saw 6. So all the factors of 6 are either less than 6 or equal to 6. As you can see, 1 is less than 6, 2 is less than 6, 3 is less than 6, 6 is equal to 6. So all the factors of a number are either less than a number or equal to a number. And now talking about multiples. A multiple of a number is nothing but the product obtained when the given number is multiplied by the same or any other number. For example, let's take the number 7. If I multiply 7 with 2, I'm getting 14. So 14 is a multiple of 7, 14 is a multiple of 2. So basically the tables that we draw, that we write are nothing but the multiple tables. That's why we call them multiples, right? So what are the multiples of 8? You take 8 and multiply it with all the natural numbers. You will be getting your, if you multiply with all the natural numbers, you will be getting a certain numbers here, right? So these are called as multiples of 8. So 8, 16, 24, 32, 40, 48, 56, 64, 72 and 80 are the multiples of the number 8. Alright? So that's the definition of multiples. Multiple is a product that we get when one number is multiplied with another number. What are the multiples of 6? You multiply 6 with 1, 6 with 2, 6 with 3 and so on. You would be getting the multiples of that number. Alright? Remember, every number is a multiple of itself. Why? Because we can always multiply 6 with 1, you'll get back your 6. Every number is a multiple of 1 because 1 into 6, 1 into 7, 1 into 5, 1 into 8 and so on. So every multiple of a given number is equal to or greater than the number itself. Now when I'm talking about the multiples of 8, all the numbers here 16, 24, 32, 48, all of these numbers are greater than 8. है ना? And this 8 is equal to 8. So the multiples of a number are either equal to the number or greater than that number. And there are infinitely many multiples. Why? Because I can still multiply 8 with 11, 12, 13 and so on. Keep on multiplying them. I will be getting, 1 minute, yeah. I'll be getting infinitely many. But factors are finite. You can count the number of factors. Infinite is, you cannot count them. And multiples are infinite. Now let's talk about prime numbers and composite numbers. Now, prime number are numbers with exactly 2 factors, 1 and the number itself. In a composite number, they have more than 2 factors. Apart from the 1 and the number itself, they have more factors. For example, let's talk about the number 32. Now, 32 ka factors kya hai? 1, 2, 4, 8, 16 and 32. Hai na? So as you can see, apart from 1 and the number itself, there are other factors also. So this number is a composite number. Now look at 43. It has only 2 factors, 1 and the number itself, which is 43. So this one is a prime number. 149 is a prime number. Now this is a composite number. Why? Apart from 1 and 121, you also have 11 as a factor. So it's a composite number, this is a composite number, this is a composite number, right? So please remember, a number, if a number has only 2 factors, 1 and the number itself, then it is called as a prime number. And if it has more than 2 factors, it is a composite number. Now we will take help of prime numbers when we are learning about prime factorizations and HCF and LCM. Alright? And now comes the tests for divisibilities of numbers. Like when you look at a number, you can just tell, is this number 3, 4, 6, 7, 3, 9, 5 divisible by 5? So I'll say yes. Within seconds, just looking at the number, I can say if a number is divisible by another number or not. How? Because there are few rules that we will have to follow. The first one, divisibility tests by 5. Now, when do you say that a number is divisible by 5? If a number is ending with 5 or 0, the unit digit of that number should be having either 5 or 0. For example, 435. Is it divisible by 5? Yes. Why? Because as you can see, the unit digit of the number is either 5 or 0. So here it is 5, so it is definitely divisible by 5. Now what about this? Now it is ending with a 0. So do you think that it is divisible by 5? Of course it is, because it is ending with the number 0. Now what about here? It is ending with the number 9. Do you think it is divisible by 5? No. Because the number is divisible by 5 only if it is ending with a 0 or with 5. Alright. Now what about divisibility of 10? If a number ends with 0, that's it. The number is divisible by 10. So as you can see, 330 is divisible. 505 is not divisible because it's not ending with a 0, no? It's ending with a 5. It's divisible by 5 but not 10. Why? Because it's not ending with a 0. 450 is divisible by 10 because it's ending with a 0. And next comes 2. 2 is very easy. All the even numbers are divisible by 2 because they'll end with 2, 4, 6, 8 or 0. So all the numbers ending with 0, 2, 4, 6 and 8 are divisible by 2. So basically the number has to be an even number to be divisible by 2. 246 is an even number, so it is divisible by 2. 308 is an even number, it is divisible by 2. 481 is not an even number, it's ending with 1. 1 is an odd number, right? So this becomes an odd number, so it is not divisible by 2. Alright, so remember, only if a number is an even number, it is divisible by 2. Now what about divisibility by 4? And if I take a number, check the last 2 digits. If the last 2 digits are divisible by 4, then the entire number is divisible by 4. For example, 216. So I'm only going to take the last 2 digits, which is 16. Is 16 divisible by 4? Yes. That means 216 is also divisible by 4. So you just have to check the last 2 digits, and this trick works only for 3 digits and more. So if the last 2 digits of a number is divisible by 4, then the entire number is divisible by 4. Now here, the last 2 digits are 23. Is 23 divisible by 4? No, it leaves a remainder which is not 0. So it's not divisible. So this entire 432 also is not divisible by 4. And next comes divisibility by 8. In 4, what did we check? The last 2 digits. Hai na? In 8, we'll check the last 3 digits. If last 3 digits are divisible by 8, then you can say that the entire number is divisible by 8. So we take 888. Is it divisible by 8? Yes. That means the entire number 888 is divisible by 8. Now here, 1569. So we are only going to take the last 3 numbers. 569. Is it divisible by 8? It is not. So the entire number is not divisible by 8. So please, for 8, you have to check the last 3 digits. And then comes the divisibility for 3. Now for 3, if I give you a number, if the sum of all the digits of that number is a multiple of 3 or is divisible by 3, then the entire number is divisible by 3. For example, 432. I'm going to add them. 4 plus 3 plus 2, that is equal to 9. Is 9 completely divisible by 3? Yes. So that means 432 is also completely divisible by 3. Another example, let's do it. 5, 5, 3. So add them. 5 plus 5 plus 3, which is 13. Is 13 completely divisible by 3? No. That means 553 is also not divisible by 3. Now, if you're confused, if you're a little weak in tables and you're confused, ki ma'am 13 is divisible or not, you don't know about it, then you add 13 also. 1 plus 3 is 4. Is 4 divisible by 3? No, it's not. So that's it. Your entire 553 is not divisible by 3. So basically, you'll have to check the sum of the digits of that number. If that sum is divisible by 3, then the entire number is divisible by 3. And divisibility for 6. Now 6 can be written as 2 multiplied with 3. So if a number is divisible by 2 and 3 and 3, okay, a number should be divisible by both 2 and 3, then it will be divisible by 6. For example, 306. Now what do we know here? 306 is divisible by 2. Yes. Why? Because the last digit is an even number. So 306 is an even number. So it is divisible by 2. Now what about 306 is divisible by 3. 3 plus 0 plus 6, 9. 9 is divisible by 3. So it is also divisible by 3. Now the number 306 is divisible by 2. It is also divisible by 3. So it is divisible by 6. Another question. 453. Now 453 is not an even number. So it is not divisible by 2. But 4 plus 5 plus 3 is 12, which is completely divisible by 3. But do you think it is divisible by 6? No. Why? Though it is divisible by 3, it is not divisible by 2. So it has to be divisible by both 2 and 3. As you can see in this one, it is 306 is divisible by 2. It is also divisible by 3. So it is divisible by 6. In this case, 453 is not divisible by 2. So you can say that it is not divisible by 6. Though it is divisible by 3 here. And then comes the number 9, which has similar divisibility rule as the number 3. Now here, if the sum of the digits of the number is divisible by 9, then the entire digit is divisible by 9. 3 plus 387. So 3 plus 8 plus 7 is 18. Is 18 divisible by 9? Yes. 9 into 2 is giving you 18. So the entire number 387 is divisible by 9. Same as we do it for 3. But for 3, the sum of the digits should be a multiple of 3. Here, the sum of the digits has to be a multiple of 9. Now 678. 6 plus 8 plus 7 will give you 21. 21 is not completely divisible by 9. So, this entire number is not divisible by 9. And then finally comes the number 11. So, for number 11, you have to add the alternate digits and subtract them. What do I mean? Now here, 3674. Now you add the alternate digits, these two. 3 plus 7, which is 10. 6 plus 4, again 10. So these two answers that you're getting, you subtract them. So you should either get the answer to be 0 or 11 or 22 or 33. So basically you should be getting the difference between these two as the multiple of 11. Then the entire number is divisible by 11. Let's take another example. 2739. So alternate digits. 3 plus 2. 5. These two numbers. 7 plus 9. 16. Now you subtract 16 minus 5. So you're getting 11. 11 is a multiple of 11. So it is divisible. So the entire number is divisible by 11. Please remember the difference that you get after adding the alternate odd places and even places. That difference should be a multiple of 11. It can be 0 or 11 or 22 or any other number which is divisible by 11. So the entire number, oh I'm so sorry. Okay, where did we go? Huh. So the entire number is divisible by 11. Alright, so that's about the divisibility rules and about the factors and multiples, prime numbers and composite numbers, and so on. In the next class, we will be jumping into something really, really important, which is prime factorization, HCF and LCM, and word problems based on HCF and LCM as well. So that is all for today's class. I hope you enjoyed it. Do not forget to comment below and let me know if you have any doubts. And share this video with at least one BFF of yours and let them also subscribe to the channel. So I'm going to see you again in the next one. Until then, have a happy weekend. I'm going to see you again in the next class. Bye-bye.